Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic Conduction of Electricity in Semiconductors. This is a topic of chemistry for class 12 students. Now see, in my previous video we have seen that in the case of semiconductors, the gap between the valence band and the conduction band is small. But the conductivity of the intrinsic semiconductors is quite low. Now, if we want to increase the conductivity, we can do so by adding appropriate amount of some impurity. Impurity means some other elements, and this process is called as doping. Now, this can be done in two ways. We can add two types of elements, and I will explain how that will help to increase the conductivity. Now see students, silicon and germanium belong to group 14 of the periodic table. Since they belong to group 14 of the periodic table, they have 4 valence electrons each. There will be 4 valence electrons, and in their crystals, each atom will form 4 covalent bond with its neighbors. But if it is doped with a group 15 element like phosphorus or arsenic, now phosphorus or arsenic contains 5 valence electrons. So 1 electron will be extra, and this will occupy some of the lattice sites in the silicon or germanium crystal. Now I will explain to you how it happens. Out of these 5 electrons, 4 electrons will be used in the formation of covalent bonds. How they will form covalent bonds? They form the covalent bonds with 4 neighboring silicon atoms. Now see, here I have explained this with the help of germanium, in which phosphorus is doped. It is doped with phosphorus. Now see, this is the phosphorus, symbol P, and this is the free electron I have labeled here, because phosphorus is pentavalent. 5 electrons it is having. With 4 electrons, it will form bond with the germanium. See, this is one bond, another covalent bond with the germanium atom, like this. Okay, but you see, I have marked here free electron. 1/5 electron is extra. Whereas in case of other germanium atoms, like see, you see, if you consider this germanium, it is having 4 valence electrons, and it forms 4 covalent bonds with the neighboring atoms. You see, here there is no extra electron. In the left side also the same kind of covalent bonding will extend. But in case of phosphorus, since it is pentavalent, we find one extra free electron, because 4 electrons will be used for covalent bond with other neighboring atoms, and one extra electron, it will be the free electron. So this 5th electron is extra, it becomes delocalized. They increase the conductivity of the silicon. This increase in conductivity is due to the negatively charged electrons, because you all know that electrons are negatively charged, and because of them only conductivity has increased. So these are known as N-type semiconductor. So this is the doping. Here also you can see, this is the mobile electron as has been marked here. This one, mobile electron, extra electron. Okay. So this is N-type semiconductor. Now next is electron deficit impurities, means if we add certain elements which are deficient in electrons. So silicon or germanium can be doped with group 13 elements like boron or aluminium. Deficit means they have less number of valence electrons than silicon or germanium. So this is possible with group 13 elements. They contain 3 valence electrons, one less than the silicon or germanium. Now, one place where 4th valence electron should be present is missing, then that we call as electron hole. And what will happen? After forming covalent bond, one vacancy is left out. So the electron from a neighboring atom can come and fill that electron hole. When it does so, it would leave an electron hole at its original position. And it seems that the electron hole has moved because the electron is coming from the neighboring position and filling the place of the hole. Now see, first of all, try to understand. I told that it can be done with a 13 group element like boron or aluminum. So here I have shown the figure with silicon and boron. For boron, this one is the hole. This is the hole. There are 3 valence electrons. Silicon is having 4 electrons, valence electrons. So with that, see, these are the covalent bonds. So boron will form covalent bonds with silicon like this. Like this. But this is the hole. This is the vacancy, this one. So what will happen? One electron can take its place. So the electron is moving in this direction. Then what will happen? The hole shifts here. The hole will shift to this place. So electron is moving in the left direction, hole is moving in the right direction. So initially where the electron was, it will go to the hole. So in its place one new hole will be created. So if the electron moves to the left side, the hole will move towards the right side. So under the influence of electric field, electrons will move towards the positively charged plate. Because electrons are negatively charged, they will move towards the positively charged plate. But it appears that the electron holes are positively charged and are moving towards negatively charged plate. Means it is going in the opposite direction in which the electron is moving. This type of semiconductors are called p-type semiconductors. Okay. So when the electron is moving towards the hole and taking its place, initially where the electron was, one hole will be created there. So the side in which electron is moving, it appears that the hole is moving in the other side. So if electrons are moving towards positively charged plate, it appears that the electron holes are positively charged and are moving towards negatively charged plate. Because the movement of holes is in the opposite direction to that of the movement of the electrons. So this is the diagram. Here also you can see positive hole. Here no electron is there. This place you see. This one electron is of the semiconductor. Boron has not contributed anything here. So there is a positive hole. No electron from boron. This is p-type semiconductor. So here I will just tell you what is happening. If boron is here, it will have 3 electrons like this. Whereas in case of silicon, it will be having 4 electrons. So it will form bond like this. On 4 sides I will do it and I will show you. So these are the 4 electrons of the silicon. Like this bonds can be formed. But here you see boron here is not having any electron. It's a hole. So under the influence of when we apply electric field, what happens? This electron, which I will show with a green colored arrow, this electron can take the place of the hole. So what will happen? One new hole will be created here. So you can see electron is moving in this direction, whereas the hole has moved from here to here. Just opposite direction you can see. The direction in which electron is moving, the hole is moving in the opposite direction. So with this diagram, we can justify this statement that under the influence of electric field, electrons move towards positively charged plate. This happens because electrons are negatively charged. It will move towards positively charged plate. But it appears that the electron holes are positively charged and are moving towards negatively charged plate because they move in opposite directions. So this type of semiconductors are called p-type semiconductors. because the electron holes seems to be positively charged, and because they are moving towards negatively charged plate, opposite in direction to the movement of the electrons. So I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to my channel. Share the channel and subscribe to my channel. Thanks for watching. Thank you all.